डियर स्टूडेंट, आज का हमारा टॉपिक है पैकिंग एफिशिएंसी। देखते हैं पैकिंग एफिशिएंसी क्या है। द मैग्नीट्यूड ऑफ पैकिंग एफिशिएंसी इज द मेजर ऑफ हाउ टाइटली द कॉन्स्टिट्यूएंट पार्टिकल आर हेल्ड टुगेदर। इसका मीनिंग हम जानते हैं कि जितना कॉन्स्टिट्यूएंट पार्टिकल्स हैं वो टाइटली हेल्ड होंगे एक दूसरे के साथ, उतना ही मोर एंड मोर विल बी द मैग्नीट्यूड ऑफ पैकिंग एफिशिएंसी। नाउ इमेजिन द यूनिट सेल। In this unit cell, the constituent particle will occupy space. Not all the space will be occupied by constituent particles, but some fraction will occupied by it, and therefore packing efficiency is the fraction of total space occupied by constituent particle in unit cell। मानते हैं कि ये यूनिट सेल है, इसका वॉल्यूम जो है ये 100% है। सो पैकिंग एफिशिएंसी इज नाउ द परसेंटेज ऑफ टोटल स्पेस ऑक्युपाइड बाय constituent particle in unit cell। इट इज आल्सो पैकिंग एफिशिएंसी। इसके बारे में हम लिख सकते हैं पैकिंग एफिशिएंसी is equal to volume occupied by all the constituent particle in unit cell divided by total volume of unit cell, and it is percentage, so simply multiplied by 100। इसके बाद हम सीखेंगे कि पैकिंग एफिशिएंसी जो है अलग अलग यूनिट सेल में या अलग अलग क्रिस्टल में, जैसे सिंपल क्यूबिक है, बॉडी स्लिटेड क्यूबिक है और फिर फेस स्लिटेड क्यूबिक है, इसके बारे में हम देखते हैं कि इसकी पैकिंग एफिशिएंसी कैसी है। नंबर 1 सिंपल क्यूबिक unit or a lattice। So in this unit cell there are 8 particles are at 8 corners। Each corner particle contribute 1/8 part for the unit cell, and therefore number of particles due to 8 corner, there are 8 corner particle contribute 1/8 part, so it is 1 particle, and therefore total number of particles in simple cubic unit cell, it will be 1 particle। Remember this। Now we have to find out packing efficiency for this straight line, radius of sphere। Now this is the front view of we are drawing here। This length is edge length A, and this is radius of sphere r. Now from this figure, the sphere or the particle are touching to each other along the edge, and therefore radius is equal to edge length divided by 2. Therefore edge length is equal to twice of r. This is equation number 1. Now our step second is volume of sphere. Now if any spherical body have volume V is equal to 4 by 3 into pi into radius cube. So putting the value of this radius from equation 1, and therefore volume is equal to 4 by 3 multiplied by pi into radius is 3 by 2 whole bracket cube. Okay, therefore volume is equal to 4 by 3 multiplied by pi multiplied by a cube and divided by 2 to 8. So very simply here 4 1 the 4, 4 2 the 8. Here volume is equal to pi multiplied by a cube 3 to the 6. So it is volume of sphere. Now our first step is total volume of all the sphere, or volume of all the constituent particles in unit cell. So this simple cubic unit cell will contain only one particle, and therefore volume of all the constituent particles in unit cell V is equal to, there is one particle multiplied by volume of one sphere, one particle, pi into a cube divided by 6. Now it is again pi into a cube divided by 6. So this is volume of all the particles. Now step 4 is packing efficiency. So packing efficiency is equal to volume occupied by all the constituent particles in unit cell divided by total volume of unit cell. You know unit cells have edge length A, and therefore total volume is equal to edge length Q. So you multiply by 100. This is formula for packing efficiency. And here volume occupied by all the constituent particles is pi into a cube divided by 6 divided by total volume of unit cell is nothing but a cube multiplied by 100. So a cube get cancelled and it remains 5 divided by 6 into 100, and it will be 52.36%. Now our next step is so this is the packing efficiency of simple cubic unit cell. Remember this. And now valid volume or white space is nothing but 100 minus packing efficiency, and simply 100 minus 52.36, it will be 47.64%, and this is packing efficiency. Now we will learn the packing efficiency of body centered cubic unit cell. Now in this unit cell there are 8 particles are at 8 corners, and one additional particle at body center. Now each corner particle contribute 1 part for unit cell, and each body center particle it contribute entirely, and therefore number of particles due to 8 corner, so each corner contribute 1 part, there are 8 corners is equal to 1 particle, and number of particles due to one body center, so it contribute entirely, and therefore 1 by 1 is equal to 1. And here total number of particles in body center cubic unit cell. So 1 plus 1, it will give 2 particles. Remember this. We need step 1, radius of sphere. So here suppose this is a body centered cubic unit cell. Look here. Constituent particles are touching along this body diagonal. Suppose this is radius of sphere, this distance. Again, this is center of this middle sphere. This again radius. This is again radius, and here this is radius. So this is the body diagonal. Body diagonal from this figure R means 4R. And now this is our edge length A. This again our edge length A. And this is edge length A. Now from this figure, body diagonal, body diagonal 4R is equal to, according to Pythagoras theorem, under root a square plus a square plus a square is nothing but body diagonal 4R. So a square plus a square plus a square, and therefore 4R is equal to 3 into a square, and therefore 4R is equal to under root 3 multiplied by a, and therefore R is equal to root 3 by 4 into a, and equation 1. Remember the equation 1. Now, step second is volume of sphere. So, formula for volume of sphere, V is equal to 4 by 3 into pi into radius cube. So, putting the value of radius from equation 1, and therefore volume is equal to 4 by 3 into pi into root 3 divided by 4 into a whole bracket cube, and therefore volume is equal to 4 by 3 multiplied by pi here, root 3 into root 3 into root 3 means 3 root 3 divided by 4 cube, 64 multiplied by 8 cube. So 4 1 the 4, 4 16 the 64, and therefore volume is equal to, here 3 cancel again, pi into root 3 divided by 16 multiplied by 8 cube. So volume of sphere. Now step 3, volume occupied by all constituent particles in unit cell. So in this unit cell there are 2 constituent particles, and therefore volume means 2 constituent particles multiplied by volume of one sphere, so pi into root 3 divided by 16 into a cube. So 2 ones are 2, 2 8s are 16. So it will be pi into root 3 into a cube full divided by a. It is nothing but the volume occupied by all the constituent particles. Now, packing efficiency is equal to volume occupied by all the constituent particle in unit cell divided by total volume of unit cell. So unit cell have alien A, and therefore alien Q means total volume of unit cell, and 4 multiplied by 100. So this now volume occupied by all the constituent particle is pi into root 3 into a cube divided by 8 multiplied by total volume of unit cell a cube. So again multiplied by a cube get cancelled, and it will be pi into root 3 under root 3 divided by 8. So you know the value of pi and value of root 3 by putting this value. The packing efficiency will 68%. Value of root 3 is 1.732 and value of pi is 3.142, and his 68% is the packing efficiency. Now y volume is equal to 100 minus packing efficiency 68%, and it will be 32%. So this way, this is the packing efficiency of body centered cubic. Now we learn packing efficiency of face centered cubic units. इसके बाद हम सीखते हैं कि पैकिंग एफिशिएंसी फेस सेंटर्ड क्यूबिक यूनिट सेल में. In this unit cell, there are 8 particles at 8 corner and 6 particles at 6 faces. Now, number of particles due to 8 corner. So each corner contribute 1/8 part for unit cell. There are 8 corner, 1 by 8 into 8 is equal to 1. And here number of particle due to 6 faces, each face contribute 1/2 part for unit cell. There are 6 faces, half into 6 is equal to 3, and therefore total number of particles in face centered cubic unit cell, it will be 4 particles. Remember this, there are 4 particles. Now for packing efficiency, we need radius of sphere. So step 1 is radius of sphere. Now this is your face centered cubic unit cell. Now in this unit cell, particles are touching along the face diagonal, and this is the face diagonal. And now this distance is radius r. Again this is radius r. This is center of sphere. Again this is radius r, and this is radius r. So face diagonal is 4r, and this is your edge length A, and again this is edge length A. And now from the figure, this face diagonal is nothing but 4r. Face diagonal is equal to 4r, and 4r is equal to, according to Pythagoras theorem, under root a square plus s square. This side square and this side square, and therefore 4r is equal to 2 into a square, and therefore r is equal to root 2 by 4 into a, and therefore r is equal to a by 2 root 2. So this is equation number 1. Now step 2, volume of sphere. Now formula for volume is 4 by 3 into pi into radius cube. So putting the value of radius from equation 1, so volume becomes 4 by 3 into pi into a divided by 2 root 2 whole bracket 2. So volume is equal to 4 by 3 into pi into a cube, 2 cube 8 multiplied by 2 root 2 into root 2 into root 2 means root 2. So here 4 1 is 4, 4 2 is 8, and therefore volume is equal to pi into a cube 3 into 2 6 into 2 12 multiplied by root 2. So this is volume of sphere. Now step 4, volume occupied by all the constituent particles in unit cell, all the spheres. So there are 4 particles, 4 sphere, and therefore volume occupied by 4 sphere is volume is equal to 4 particles multiplied by pi into a cube divided by 12 into root 2. So very simple, 4 1 is 4, 4 3 is 12. And now packing efficiency, step 4. Packing efficiency is equal to volume occupied by all the constituent particles in unit cell. So it is percentage, so multiplied by 100 divided by total volume of unit cell. So edge length of unit cell is 8, and therefore total volume is nothing but edge length cube. So packing efficiency is equal to volume occupied by all the constituent particle, it will be pi into a cube divided by 3 into root 2 multiplied by 100. So you know value of pi and value of under root 2. So it becomes 74%. And now white space or white volume is 100 minus packing efficiency. So simply 100 minus 74 is nothing but 26%. This way, this is the packing efficiency of face sector cubic unit cell is 74%. So this way. इसके बाद हमको सीखना है number of atoms and number of unit cell in x gram मेटालिक क्रिस्टल। आपको एक फार्मूला पता है, डेंसिटी इज इक्वल टू मास अपॉन वॉल्यूम, बट डेंसिटी ऑफ यूनिट सेल की डेंसिटी निकालना, इसको रो कहेंगे। नंबर ऑफ एटम्स in unit cell divided by total volume of unit cell, unit cell का total volume multiplied by molar mass divided by Avogadro's number। इससे हमको फार्मूला तैयार हो जाता है, डेंसिटी इज इक्वल टू नंबर ऑफ एटम्स इन टोटल वॉल्यूम एज एन क्यूब, सो मल्टीप्लाइड बाय मोलर मास डिवाइडेड बाय अवोगाड्रो नंबर। हम m के लिए यहाँ पे इक्वेशन बनाएंगे, m इज इक्वल टू रो मल्टीप्लाइड बाय, इधर जाएंगे a क्यूब इनटू अवोगाड्रो नंबर डिवाइडेड बाय नंबर ऑफ पार्टिकल, एंड दिस इज इक्वेशन नंबर 1। नाउ our question is number of atoms in x gram crystal, x gram metal। So here number of atoms in x gram metal, x ग्राम मेटल में कितने एटम्स होंगे। आपको पता है किसी भी सब्सटेंस के मोलर मास में एवोगाड्रो नंबर इतने पार्टिकल्स होते हैं, ठीक है। नाउ मोलर मास m, इट कंटेन कितने पार्टिकल्स होंगे, एवोगाड्रो नंबर इतने पार्टिकल्स होंगे, and therefore x ग्राम मेटल कंटेन, x ग्राम मेटल में कितने पार्टिकल्स होंगे, क्रॉस मल्टीप्लिकेशन करेंगे, इज इक्वल टू x मल्टीप्लाइड बाय एवोगाड्रो नंबर डिवाइडेड बाय मोलर मास। सो वी पुट द वैल्यू ऑफ मोलर मास and it is x into Avogadro number divided by rho into a cube multiplied by Avogadro number। यहाँ का n जो है ये नीचे है, यह ऊपर चला जाएगा, कॉमन कॉमन कैंसिल हो जाएंगे, सो इट विल बी x into n divided by rho into a cube। दिस इज द नंबर ऑफ एटम्स इन x ग्राम मेटल। इसके बाद हमको सीखना है नंबर ऑफ यूनिट सेल इन x ग्राम मेटल। और आपको प्रॉब्लम आता है उसमें हम सीखेंगे नंबर ऑफ यूनिट सेल इन x ग्राम मेटल। तो मान लीजिए यहाँ पे आपकी एक यूनिट सेल है और इस यूनिट सेल में n नंबर ऑफ पार्टिकल। ये जो यूनिट सेल है सिर्फ मान लीजिए कि यहाँ पे एक यूनिट सेल है। अब आपको इससे एक बात पता चल जाती है कि n नंबर ऑफ पार्टिकल करस्पॉन्ड टू वन यूनिट सेल। तो अपने पास जो पार्टिकल है दैट मच पार्टिकल करस्पॉन्ड टू हाउ मेनी यूनिट सेल्स। वेरी सिंपल, यहाँ पे देखो नाउ n particles corresponds to वन यूनिट सेल। मान लेते हैं कि एक यूनिट सेल में कितने पार्टिकल्स है, n नंबर ऑफ पार्टिकल, एंड देयरफॉर हमारे पास पार्टिकल है x into n डिवाइडेड बाय rho into a क्यूब। पार्टिकल्स corresponds to how many unit cells। यहाँ पे क्रॉस मल्टीप्लिकेशन करेंगे, is equal to 1 multiplied by x into n divided by rho into a cube। n इस साइड में है तो n को यहाँ, तो n जो है कॉमन है, कैंसिल हो जाएगा, बचेगा x divided by rho into a cube। दिस इज नथिंग बट द नंबर ऑफ यूनिट सेल इन x ग्राम मेटल। इसके बाद जो है अगर आपको इसने पूछा नंबर ऑफ यूनिट सेल इन द वॉल्यूम, So it is very simple, G divided by वॉल्यूम क्यूब. So these are the फार्मूले. ये फार्मूले जो है आपको काम में आएंगे न्यूमेरिकल्स सॉल्व करने के लिए. थैंक यू.